Shettima Tutors. Now we're talking about questions of motion. First of all, what is acceleration? Acceleration is defined as the rate of change of velocity over time. In other words, the body's velocity increases, decreases by equal amounts in equal time intervals. So that's it. The difference between velocity and speed is that velocity is a vector quantity while speed is a scalar quantity. While velocity has magnitude and direction, speed has only magnitude without specific direction. No specific direction in speed. Speed does not have a specific direction. As for a car in motion, there are vertical forces and horizontal forces acting on the car. As for the horizontal component of the force, you have the thrust force. The thrust force acts forward, which is produced by the engine to push it forward. And then there's an opposing force, which is the restrictive frictional force and air resistance acting in opposite direction against the car. These are the horizontal forces. As for the vertical forces, you have the weight of the car, which acts downward due to gravity. Also have the normal reaction of the surface of the road against or upward, which is exerted by the road surface on the car. Now let's attempt this question. A car starts from rest and accelerates uniformly for 20 seconds to attain a speed of 25 meters per second. It maintains this speed for 30 seconds before decelerating uniformly to rest. The total time for the journey is 60 seconds. Deceleration means continuous reduction. Acceleration means continuous increase in velocity. So now we want to analyze this question. Let's analyze it. The first thing is, what is the initial velocity? The initial velocity u is given as 0. According to the question, initial velocity is 0 because it starts from rest. Then final velocity v is 25 meters per second. According to the questions, is the first time it takes 20 seconds time t. Second time 2 is 30 seconds. And then you have the total time. According to the questions, it tells us that it's 60 seconds. Then the time 3, you're going to do t minus t1 plus t2. You have t1, t2 to get time 3 is going to be the major time, the total time, minus time 1 and time 2. Time t, total time was 60 according to here, minus 50 here, it gives us 10. 60 take away 50. So 10 seconds. Now I want to draw the velocity time graph. So in my velocity time graph, I'm going to have vertical component and horizontal component. So this is the first step, graph of velocity against time. Velocity in meter per second, time in seconds. Then we have our origin 0 here. Now according to our question, our initial velocity is 0, which is here. And then the final velocity is 25. So let's say 5, 10, 15, 20, 25. Having done that, you also want to consider the time. This velocity, 25, highest velocity. The highest time is 60 seconds. So we're going to break it. Let's say we could graduate it into maybe 10, 20, 30, 40, 50, and 60. Therefore, according to the question, it says the car starts from rest, which is 0 initial velocity, and then accelerates uniformly for 20 seconds. For 20 seconds, that means accelerate till it gets to 25 meters per second square for 25 meters per second for 20 seconds. So it accelerates to this point for 20 seconds. So the meeting point should be 25. That's 25 meters per second. Then for 20 seconds, trace 20 seconds upward here. So upward here. Then you say from 0 it accelerates to this point. So this is the first time. Then after that, it maintains a constant speed, constant speed for the next 30 seconds. So we'll draw it here to meet it here because it's constant. At this point, this is the highest velocity reached. So after, when it gets to this velocity, no more acceleration, it moves at a constant dimension. So if you have 20 for T1, T2 is going to be T1, T2. That's for 30 seconds, 10, 20, 30. Constant speed. Or it later decelerates. That means it decelerates until it gets to 0. It decelerates from 25 meters per second. At this point, it begins to slow down until it gets to 0. Here we go. So this is going to be T3. T3 is 10 seconds here. So we have 10 seconds here. Then the total distance traveled is area under the trapezium. Of course, this is the shape of a trapezium. If you like, you can break it into A, B, and C. First triangle, area of the first triangle, plus area of this rectangle, plus area of this triangle. Or you just do area of a trapezium. And area of a trapezium, it's half times A plus B times height. A plus B is the parallel sides. A is 30. B is 60, all from here to here. So 30 plus 60 times the height. The height is from here to here. That's 25. Half times 90 times 25. Of course, 2 here, 2 in 90 is 45. And then 45 times 25. Let's see what it gives us. Gives us 1125 meters. So the area is 1125. So the total distance travel, which is the area of this trapezium, is 1125 meters. Went further to say find the deceleration of the car. In checking this, when it was at this first phase, it was accelerating until it got it with initial velocity was 0 and final velocity was 25 meters per second. Then it maintained 25 meters per second at this point. So at this point, it was 25 meters per second. That means that until it continues to decelerate till it becomes 0. So the deceleration part, the u initial velocity will be 25, final velocity v is going to be 0. So this since we're talking about acceleration is change in velocity all over time. So for the deceleration part, the final velocity is 0, which is v. Final velocity v is 0. Initial velocity 25 all over time. So what is the time for this distance? That's 10 seconds. 50 to 60 times 3, 10 seconds. So I'm going to just write 10 here. 1, 0. This is going to be 10 equals to minus 25 all over 10, which is equals to minus 0.25. Minus 0.25 meter per second square. This minus shows that it's decelerating, or you can just say deceleration is 0.25 meters square per second square. 0.25 meter per second square.